Welcome to a concise tour inside the modern LNG receiving terminal, where we'll explore the core processes and recent innovations shaping gas infrastructure. Over the next slides, I'll walk you from ship arrival to regasification, highlighting key equipment, operational choices, and how new ideas are improving safety, cost, and performance across the supply chain. Global LNG trade has been steadily rising, driven by growing power demand and the appeal of natural gas as a cleaner, flexible fuel. The slide's chart shows an upward trend in trade volumes, while the diagram maps the chain from gas fields through liquefaction, vessel shipment, and finally to the receiving terminal, where regasification and distribution occur. At the heart of every terminal is a simple mission: receive LNG from ships, store it safely at cryogenic temperatures, and turn it back into gas for the pipeline. The process flow diagram illustrates unloading, storage tanks, pumps, vapor handling, and vaporizers, while the listed components emphasize jetties, tanks, pumps, and vapor systems that make continuous delivery possible. Arrival is a carefully choreographed transfer from sea to shore, using articulated unloading arms to move cryogenic liquid into onshore tanks, while a vapor return line maintains cargo pressure. Typical unloads take roughly half a day to a day for large ships, with standard rates and safety steps designed to protect crews, vessels, and nearby communities during the transfer. Unloading has seen innovation to reduce coastal impact and costs, driven by local opposition to large onshore jetties. New approaches range from longer reach systems to offshore turrets and subsea cryogenic pipelines that keep heavy infrastructure offshore, cutting shoreline disturbance and enabling flexibility in where terminals can be sited. Storage holds the energy at roughly minus 162 degrees Celsius and buffers shipments to maintain steady pipeline supply. Tanks come in single, double, and full containment designs, each trading off footprint and safety. The images show large cryogenic tanks and cross sections that explain how secondary containment and concrete walls are used to meet different site needs. Storage innovation trends toward larger, smarter tanks to lower unit costs and improve safety. Modern designs use top and bottom fill points to avoid dangerous stratification or rollover, and partial hydro testing has emerged as a cost-saving foundation strategy that keeps safety high while reducing construction load and expense. Stage 3 is the engine room, where pressure and flow are managed. Submerged first stage pumps raise pressure, and subcool LNG recondensers capture boil off gas, and high pressure multi stage pumps push product toward the vaporizers at pipeline injection pressures. This combination minimizes waste and stabilizes delivery pressure for the downstream system. Transforming LNG back to gas uses different vaporizer technologies depending on resources and needs. Open rack vaporizers use seawater in a falling film arrangement for baseload supply, while submerged combustion units burn a bit of gas to heat a water bath for peaking or backup. Each choice balances CapEx, OpEx, and typical use cases. Traditional vaporization wastes a lot of the LNG's cold, but that cold can be harnessed. The slide highlights cold utilization opportunities like air separation, CO2, and dry ice production, and, most powerfully, integrating the terminal with gas turbine plants to chill inlet air and boost power plant efficiency and output. Colder inlet air means denser charge and more power from the same turbine, a science that translates to measurable gains during hot months when demand peaks and turbine efficiency drops. The chart illustrates incremental power gains from inlet chilling, showing tangible value where grid stress and peak prices are highest. Every terminal is unique and costs vary by site, as shown by the project cost pie and key drivers. Tanks and process equipment take a large share, but marine conditions, onshore soils, storage containment type, and whether power is generated on site or imported can each add millions. So careful siting and design choices are essential. The global map highlights a wave of new terminals and expansions from new builds in the US and Mexico to growth in Southern Europe and China's recent market entry. Regional investment patterns reflect demand diversification, supply security goals, and evolving trade routes that are reshaping the LNG terminal landscape. Looking ahead, terminals are becoming smarter, more efficient, and more adaptable. Cold energy utilization and plant integration drive efficiency, siding pressures accelerate offshore and subsea solutions, and scale plus refined design practices push down unit costs. The industry is evolving under dual pressures of cost reduction and environmental responsibility, shaping future projects.